Welcome to the Neural Implant Podcast, where we talk with the people behind the current events and breakthroughs in brain implants in an understandable way, helping bring together various fields involved in neuroprosthetics. Here is your host, Ladan Jiracek.
Hello, everyone. Welcome to the Neural Implant Podcast. Today's guest is Francesco Petrini. Did I say it? Is that Italian enough? So he is the co-founder and CEO of SensArs, and SensArs is looking to recover function for diabetic neuropathy and feeling sensation for those who have had diabetic damage to their nerves. So you may have heard about people needing to be amputated after getting diabetes, and this is often because they get injured in their foot and they don't know because they've lost sensation in the nerves, and then they have to get amputated, and that's not good. Francesco, do you want to tell me a little bit about yourself and the company and introduce yourself better than I just did?
Yeah, with pleasure. Thank you very much for having me. And it's really fun to do these activities to speak about neurotech. I loved how you said my surname, Petrini. That's exactly how Italians would talk about it. English people would say Petrini, which I got used to say every once in a while to make sure that people really understand it. But thank you very much. The introduction was quite accurate, I want to say. And we can just add the concept of diabetic neuropathy, which I'll explain in a second, which is basically what you were talking about, damages to the nerves because of diabetes. That is called diabetic neuropathy. Me, myself, I'm a biomedical engineer by training, and then I started my career in university. I traveled through some of the top universities in Europe. I was at Imperial College of London, ETH of Zurich, EPFL of Lausanne. I started everything in Rome, where I was born and grown at Campus Biomedico of Rome. And the biggest achievement that I reached in university was to do the first implants of electrodes inside the nerves of patients with an amputation, with the novelty of the electrode being that this electrode was being implanted inside the nerve. So everything in neurotechnology that's available today is something that is implanted outside the nerve, outside the spinal cord, right? We do something that is new. And why do we do that? Because in this way, we really achieve the highest selectivity, the highest precision in stimulating inside the nerve. And the highest precision is what enables us to restore sensation that these patients do not have anymore because the nerve doesn't do anymore what's supposed to do because of a damage, because of an amputation, whatever. During the university, I've done experiments on animals first to take these electrodes to humans. And then I had the chance of doing experiments with 7 patients who had lost or the hand or the leg. And what I was doing was really to restore sensation from the leg that they didn't have anymore and to match sensations with the prosthesis, meaning the patient now is using a prosthetic hand and is squeezing an object, and the person is really feeling that object with the prosthesis that by definition doesn't have sensation. Thanks to the stimulation of the nerve, now you can enable the patient to feel an object while squeezing. Or if speaking about the leg, now you can have a patient walking and feeling the surface on top of where the patient is walking. Now, because of these researches, I received recognition from the MIT as a top innovator under 35. And after that, I really went full capacity, full energy, as if it was a baby, into SensArs. And SensArs is using this product to solve the challenge of complications of diabetic neuropathy. Diabetic neuropathy per se is a complication of diabetes. You have diabetes, you have the blood flow that is altered. In particular, you have too much sugar in your bloodstream. Too much sugar damages the nerves. And so the nerves, in particular in the legs, stop functioning. When the nerves in the legs stop functioning, people lose the sensations from the feet. And as you perfectly said, when you lose a sensation from the feet, you do not recognize whether there is an ongoing damage. You do not manage to walk physiologically anymore. So you tend to put too much pressure over areas of the feet that when they get this pressure over and over again during walking, they damage the skin under the feet, damages. And in this way, the patient goes through an ulcer, and the ulcer is very complicated to treat and very often ends up in an amputation.
Interesting. So I thought the ulcers occurred because of some kind of injury or something like this, but you're saying it's from the walking and walking incorrectly or something like this?
That's very true. The ulcer, which is the predecessor to an amputation, the amputation occurs because the ulcer cannot be treated. Okay, the ulcer is advanced too much. Now, an ulcer can occur for different reasons. When we talk about diabetic neuropathy, it can happen because there is an external stimulation, an external reason for damage. For example, the patient doesn't feel and so walks on the sand that is very hot, and it's so hot that it can burn the skin, but the patient doesn't feel it. So this is one example. Or if you have a pebble in the shoe, this is when there is an external factor that is really causing a damage that you cannot detect. Another reason is that you not having sensation from the feet, not having the system that usually regulates how you walk, because usually you have sensation from the feet, you have the sensation of movement from the feet and legs, and those sensations you use for maintaining a balanced walking. When you lose those sensations, the balanced walking doesn't occur anymore. So you put too much pressure over the side of the foot, for example, and you don't realize it. And you keep walking on it, you keep walking on it, the portion of the foot simply breaks. And that leads to an ulceration, which finally leads to an amputation.
Wow. Yeah, fascinating. I haven't known too many people, unfortunately. I have seen this just walking out and everything like this, that this can be an issue. And so why particularly this indication, and what inspired you to get into this, and how is your technology suited to improve it?
Right. Well, the reasons that we decided to go with SensArs into diabetic neuropathy is because, one, standard of care unfortunately is still not well suited for solving the problem of ulceration. To give you an idea, if you're a patient that has developed an ulceration, you have a 40% chance after you heal from this ulceration to get another ulceration within 1 year. And in 70% of the cases, you get an ulceration within 3 years. Okay, so the standard of care is not being able to prevent that the ulcer reoccurs. In terms of when you develop an ulcer, treatment is a disaster today because patients on average spend 3 months in and out the hospital for treating the ulceration. Imagine of all the costs that are associated with the patient not being able to go do their own activities because they need to go to the hospital to get the treatment. Plus the mental burden on the patient. So those patients basically stop doing a rich life anymore. And in 2026, this is something that we can really not allow. And that's why we said, okay, why does the standard of care fail? Because the options that are used today, which are mainly offloading shoes, so the shoes that release the pressure from the area where the patient usually puts too much, or daily inspection and application of creams. Those are approaches that are very complicated for a patient to stick to for a long time. Indeed, adoption of the offloading shoes is as little as 30%. 70% of patients after a while say, no, but those are annoying and they are bulky and they are ugly to see. So they just stop walking. And applying creams and doing a daily inspection, that's super complicated. I don't know if you ever had to cure a chronic condition where you need to put your attention every day. It's super complicated. It's super complicated. Also for me, I don't have that kind of problem, but I had to do something like that. Super complicated to do. So patients don't stick to that. And we said, let's go to the root of the problems. And those patients lose the sensations. Because they lose the sensations, they don't know what's going on. They don't have a perception of risk of what's going on anymore. Let's just give them back the sensations so that they do the job by themselves. And this is why we decided to go for sensory restoration for diabetic neuropathy. I told you already the burden on the patient. They lose the ability of having a rich life. There is also a problem for the physicians. They are a little bit overwhelmed because they see all these patients for which they cannot do so much, right? Because they can just offer the shoes or the daily inspection and not much more. And the healthcare system Not everybody knows that, but the complications of diabetic neuropathy cost every year, all in the United States, something around $80 billion. And this is something comparable to cancer. So complications of diabetic neuropathy are some of the top four most costly expenses today. So we need to solve this problem. We really need to solve this problem. And sensory restoration is not available. So we need to give this tool.
Yeah, that's really impressive. This episode is sponsored by blackswan-ip, a boutique law firm specializing in intellectual property for neurotech and medtech startups, founded by Eugene Daneshvar, who holds both a JD and PhD in biomedical engineering. blackswan-ip helps innovators secure patents, develop smart IP strategies, and even navigate funding. Whether you're an early-stage startup or scaling your medtech venture, they'll work with you using flat-fee pricing and deep technical expertise. Learn more at blackswan-ip.com. So what does your technology look like? Can you describe it a little bit? Are you wearing some shoes that then send that signal, or are you using the actual nerves and actual temperature? You also mentioned walking on hot sand, using the actual temperature sensors, and you're just amplifying it or something like this. And then what kind of resolution? You had mentioned before that you were doing invasive versus surface level or cuff electrodes or something like this. What kind of resolution, or how many channels are you able to see? What kind of dexterity or precision is the patient able to have?
Of course. So first of all, how the product is structured, how the product looks like. The product has an implantable part and an external part. The external part is indeed a sensorized insoles with, in the first generation of the product, pressure sensors and movement sensors, an IMU, which basically detects the movement of the foot. This information is delivered to the implantable system. The implantable system is constituted by an implantable stimulator, basically a battery that creates the energy to send to the electrodes, which are implanted inside the tibial portion of the sciatic nerve. Why? Because that's the portion of the sciatic nerve that is responsible for the sensations from the bottom of the feet. Now, what happens is that the patient does a surgery. After the surgery, there is a calibration, meaning that the stimulation is characterized for the specific patient. And then with this information, we connect the insole with the stimulation, meaning that if the patient is walking on a sensor that is positioned in the heel, we know which is the stimulation that we need to deliver for activating a sensation from the heel. And that's exactly the connection that we make, meaning that now the patient walks and every time touches with the heel or the middle of the foot or the top of the foot, a corresponding sensation is delivered, and so they really feel what's going on at the level of the feet. Now, this is really the physical product that the patient gets. There is also a software component that is very important today in the era of AI. Since we're acquiring data from the insole sensor all the time that the patient is walking, that information we store and we process and we send back to the patient and the clinician so that the clinician can know at all times if the therapy is doing good and if the patient is eventually walking in a way that will lead to an ulceration. And the patient can receive some similar information with some motivational messages so that they're always also informed on top of feeling because of the physical device if they're doing something wrong.
Are the shoes more attractive than the alternatives right now? And then would it be necessary? Could you do this just with the shoes, for example, without the implantation and just have an app or something like this and it's sending off the same thing, or gives a notification on the phone if you're stepping incorrectly or something like that?
Let me respond you first to the remaining portion of the question that you asked before. Why doing this with an implant in the nerve? When I started to look into this product, what I found is that if you try to do nerve stimulation with a cuff or with a electrode that is positioned close to a nerve or stimulating the nerves from the skin, so from outside the body, it is known there are several results from different pilot studies that show that you manage to elicit that sensation that covers only 20 to 40% of the foot. This means that if you have the entire foot, now you release it in sensations only from the top of the foot or the bottom of the foot. Now, if you want to make the patient aware at all times if there is a danger in the foot, if you're giving information only about 20 to 40% of the foot, you're not going to be able to cover all the dangers. And so the patient sooner or later will get some ulcer again, even with those devices. In our case, since we have this novel implantation inside the nerve, we can reach out to the entirety of the nerve in a very precise way. So we can really teach the nerve how to activate again after damage has occurred. So this is the reason for doing it implantable. Then you asked me about is the shoe more attractive? We don't do shoes. So the patient can use whatever shoes they want because what we give is an insole that goes inside the shoe. In this way, we also solve the problem of compliance for the patients. Why? Because we're not asking the patients to think about it anymore. They can take as many insoles as they want, place them inside as many shoes as they want, and then every day they just go and take their own shoes. Of course, attention, if you want to wash the shoes, take the insole first because there is electronics, and then wash the shoes and then place the insole again. But we don't need to create particular shoes.
Okay. Yeah, very cool. That and then as for the just making an insole, for example, and then having that be like an app connected and also sending to the doctor, did you find that there's more adherence, or because it's more natural, they listen to what the insole is telling them, or what's the advantage of having the implant, the high resolution implant that they can feel the whole of the foot?
You have at least a couple of advantages. The first one is compliance, which I mentioned. You don't need to make the effort of wearing something. For example, if we decide to go for a sock, now the patient would have needed to think all the time to wear that specific sock because otherwise there wouldn't have been any product functioning, right? While instead, if you place an insole inside every shoe that the patient is wearing, the patient just goes to get the shoe, wears the shoe, and doesn't think about it. And the product activates automatically. This is what happens. The other advantage, why implanting inside the nerve? Because if you implant inside the nerve, you can cover the entirety of the foot, this we said. If you cover the entirety of the foot, you can detect the danger from everywhere in the foot. The problem is that you cannot predict where the danger will occur. Ulcers can occur at the bottom of the foot, at the side of the foot, at the level of the toes, or the area of the foot, the metatarsal area that is just before the toes. So if you don't manage to cover all those areas, you don't manage to give information to the patient, sensation of the foot to the patient of a danger, any danger that is occurring.
Got it. And that danger is pretty fast or pretty timely. You would need to know to fix it within a few minutes. You couldn't, at the end of the day, get a report and say, oh, by the way, you were putting too much pressure on the metatarsal area. You should watch that for the previous thing or for the next few days. But that would be something that you need to fix right away. Otherwise, you could, by the end of the day, have some kind of injury. Is this correct?
That is correct, but it is correct in a sense that there are ulcers that occur very quickly because the patient now is deciding to do some very quick activity and without realizing it, putting too much pressure for 5 minutes over the same area of the foot, that area of the foot damages. But also, let's suppose that you have now an insole that detects and sends the feedback to the patient that throughout that day of use, there were a few dangerous conditions. Now, the patient continues to not feel the feet if you just give the insole. So not feeling the feet, it's complicated for the patient to just control, to do something different. So what usually happens is that the patient just doesn't do anything. And that is not what we want to achieve. We want the patient to really feel comfortable to go back into doing all the activities of daily living as it was before. This is what neurotechnology should do. Neurotechnology shouldn't just manage the symptoms. Neurotechnology shall allow the patients to go back to the life before there was even a problem.
Yeah, very cool. Yeah, I think this is great, and hopefully you're able to help some people. So what stage of the company are you? When did you found it? And are any exciting things coming up?
So I mentioned before that we can leverage already some first-in-human studies that we've done in amputees. They are extremely relevant because in amputees, we've implanted a portion of the nerve in the mid-level of the thigh that will be implanting also in patients with diabetic neuropathy. And both in amputees and in patients with diabetic neuropathy, the portion of the nerve is healthy. So we tested what happens when you implant a healthy portion of the nerve. And this applies also to me and you. If me and you get that same implant, we would be getting the same feelings that we've elicited to amputees. So the studies that we've done before are very relevant. Also, we not only have demonstrated that the patients feel sensations, but we've also demonstrated that the patients can use those sensations for doing better. Talking about patients after leg amputation, so talking about walking, what we demonstrated is that the patients now use the sensations to increase their confidence and walk 30% faster, go on uneven terrains 30% faster, or climb the stairs 30% faster. They reduce falls by 80%. And also, when patients have pain because of the nerve damage, that pain goes away. Now, after all the lessons from these previous studies that we've done, we've upgraded the product. The majority of the product is already tested and ready to go to clinic. There is a portion of the product, in particular the stimulator, that needs some additional testing. After that, we're gonna be ready to go to clinic again and do a confirmation study with 10 diabetic patients that have the condition of diabetes, and after that be ready for a commercial study. Now, the timeline that we have in front of us is a 3-year timeline, at the end of which we envision to be approved for commercialization. And our targets are the United States and Europe.
Great. I'm curious about your personal journey too. It seems like you were, like you said, in all the most famous universities and maybe had a good academic career in front of you. So what made you change or jump out of that and jump into entrepreneurship? And what was the timeline of that? What made you think, when did everything happen?
You are right. You are right. I still am some of the most successful researchers. If you look at the statistics, how many papers you published, the impact factor, which basically is a proxy of the impact that your research had, because it basically monitors how many people are reading of your research. Eventually, what I was really missing when I was in university was the possibility of responding to patients that were asking when that technology would have been available for everyday use. Now, when you are in university, in the majority of the cases, what happens is that you test something that remains in university. Somebody else needs to take it and then do the commercial path. I was tired of doing the proof of concept, of arriving to a patient and having to respond, man, sometimes in the future, right? So I took that responsibility in my own hands, and I decided to work at bringing this technology and so today product to the patients for everyday use.
Okay. Yeah, and so what was the timeline of that? When did you decide to do that? And what was that founding of the company? And then what are you doing, dilutive for getting investment or non-dilutive getting grants? And if you did talk to that patient now, you'd say, in 5 years, I'll have a solution for you or
That's it.
something like that.
That's it. So I started to think of SensArs already when I was born. In a sense, I've always wanted to, at some point, have a company that was responsible for bringing something that would have changed the lives of people. So this was always my aspiration. But then I started the university career for investigating more over an area that I really loved, which is neurotechnology. And eventually, pretty quickly, I was lucky enough to be part of a team that was starting these experiments. So I had the first experience with patients in 2013, and in 2013 I was already thinking with my colleagues of the time to go through this adventure. Eventually, we created the company in Switzerland in 2014, but the company was a tool that we created to support the ongoing researches that we still needed to do. And the research's activities continued until 2019. After that, I worked very hard at getting some financing for creating a more commercial product. I succeeded in that via grants, which kicked in 2020. So in 2020, I started to work at a novel, more commercial version of the product. I studied the different use cases in which this product, this technology could be brought. And eventually in 2024, we officially started to dedicate to the mission of diabetic neuropathy and the prevention of complications of diabetic neuropathy.
Wow. Yeah, very cool. It's a long journey, decade long, and you had that goal from the very beginning. Yeah, I think this is great, and hopefully you guys have a nice progress, are able to improve the symptoms, and like you said, get past just like a band-aid or alleviating the symptoms, but actually fix the problem, like you said, and that they're able to potentially learn to walk. And yeah, so I guess, who is this technology, this implantable technology within the nerve, is this something that you would recommend to others as well? Or is this specifically suited for your indication of this diabetic neuropathy? Or do you think more people should be investigating this intranerve stimulation and sensing?
As a matter of fact, sensory restoration can be very useful for patients wearing a prosthetic device because they're using a device that does not have any sensation. So having now the sensations back can really help them controlling using the device much better. And this is something that we've eventually already demonstrated. It is also useful for patients with distal pain that is due to a nerve damage, for example, pain in the feet or pain in the hands. Today, neurotechnology eventually dedicates to quieting the nerve. So all the pain signals that want to go to the brain and disrupt the daily activities of the patients, the neurotechnology of today works at quieting them. What we would do instead would be to really restore the natural sensations to the brain so that the little by little the brain understands that there is no problem at the nerve anymore and the pain signals do not even arise and arrive anymore.
And then actually, I just thought too, you are dealing with the diabetic neuropathy and the diabetes is killing the nerves. What's to say that the nerves that you've implanted into, that you're restoring the sensation into, that they don't die as well? It does go from the extremities and into the core, right? So eventually, maybe that signal gets lost too?
No, that's a fantastic question. Now, what we know clinically is that in the majority, really 99% of the patients with diabetic neuropathy, the neuropathy arrives to the level of the knee. The neuropathy is really something that gets the structures that are smaller and more fragile. So when you are below the knee, there you have nerves that tend to be smaller in caliber than the same nerve just above at the level of the thigh. Luckily for us and for the patients, the nerve in the level of the thigh where we do the implantation is not affected by the degeneration.
Okay. Okay. Very cool. Yeah, Francesco, this has been great, and I wish you lots of luck. Is there anything that we didn't talk about that you wanted to mention?
I think that you covered it well. I want to say, yeah, those are the things that are going to be the most interesting for someone that goes and listen for the first time to this problem. Yes,
Yeah,
man. Thank you very much.
excellent.
Hope you enjoyed the show and were able to learn something new, bringing together different fields in novel ways. Until next time on the Neural Implant Podcast.